here is this hydraulic cylinder. We have got the hydraulic cylinder. This is that steel one is a hydraulic piston, and of course the cylinder and piston, they must work in harmony. And another important feature or the constructional detail of these earth moving tractors is the linkages. The mechanical engineers, they have worked a lot on designing and optimizing these linkages and placement of these muscles, aka the hydraulic cylinders, so that it can improve the efficiency of the entire work. It can get better mechanical leverage at the cost of the lateral and longitudinal stability of the tractor. Because what happens, what I'm actually talking about is, if you are pushing certain load, it may be also required that you need to, just tilt it. From where you can tilt? This tilting can be done with the help of system A or system B. Hydraulic system, hydraulic circuit A or hydraulic circuit B. I want that to be tilted. I want this thing to be, this bucket to be tilted, let's say upward. What do you think? Which hydraulic system should be activated?
I think it's B.
Yes, it's with B, because as you can see that it is connected to this linkage here, and with A you can actually lift it up. But lifting will require the coordinated efforts of both the systems A and B. So here the control of these earth moving tractors is not that straightforward. By the way, they do not usually have the steering, unless you have got this these wheeled tractors. Here we have got the crawlers. We have got this chain, right? Endless chain, single full length chain. So they have got the hydraulic levers, and those hydraulic levers, they are simply bringing the motion to this sprocket. This is the only live thing over here. It's only one thing, okay? It's only single axle, which is live, and rest of the things we will see. This is part of the tensioner. This is a part of this the chassis, and here we have got the idler, and here we have got the rollers. So it's a simple mechanism, but it's quite complicated to operate, because we have to make sure that we are using these different levers to activate these different hydraulic systems in harmony, so that you can push it forward to fill the bucket, and at the same time you kind of make a scrape at the ground with these teeth of the bucket or teeth of this dozer, so that you can bring the material in inside the bucket. You can fill it to the full capacity, and then move it from place A to place B. And they contain large plates. These blades or plates, these are known as the dozer blades, and these are used to push the rock or earth or all these kind of construction material. Then we have got the excavators. They are also popularly known as the JCBs. JCBs are like Xerox or Jeep. Now, Xerox is just a name of the company which introduced the photocopy machine, at least in India. I'm not sure about whether these are the pioneer worldwide or not, but we popularly call it as, okay, have a Xerox. So similarly, JCB is just one of the company. I'm sure that you may be knowing this company, because this may be your potential employer in future. So these are popularly known as JCB, but actually these are the excavators. So these are very popular for digging. How they can dig? Because they have got their teeth here. This is the bucket, and they have got the teeth, and they can also be used for demolishing. So if you have seen the the BMC, right? BMC is quite infamous for using excavators, JCBs to demolish the unauthorized constructions. So whose house? I think it was last time. It was Kangana Ranaut's office was demolished by BMRC. It's BMRC or yeah, I think Brihan Mumbai Municipality Corporation or something. Now recently, whose office was demolished? Was it Shah Rukh's office, right? You guys don't read news, huh? Okay. So they have got these buckets which are quite longer and sizable, so that it can actually carry the load. Now there is a difference between excavator and loader. The same thing if it is front mounted, because it is a front end loaders, front end or front mounted loaders, FELs, the direction of these buckets will be different. This will be simply the mirror image, so it can scoop up while making a forward stroke. So that is the difference between excavators and the front end loaders. Here it is also a loader, but it's backhoe loader. So it has this mechanism of contracting, not expanding. So that is the difference between the FELs and the backhoe loaders. So we have talked about the bulldozer. We have seen how an excavator looks, and here this is the backhoe loaders. Here we have got a shovel in the front. So this shovel is a kind of a mini dozer. Mini dozer. The purposes are different. Shovel are used to fill the earth and then move it here and there, because here the lift is more. But in case of the dozer, the vertical lift is restricted. Here more emphasis is on to push the higher volume of the soil. But here in case of the shovels, the emphasis is not on demolishing, or emphasis is not on scrapping the earth as the dozer can do. So there is a little difference between the two. That's why this this bucket is not called as the dozer, but it is called as the shovels. And this part is stabilizer. It is very important. You may have also noticed that in the previous two designs, in the previous two machines, we do not need these kind of stabilizers. This is known as the stabilizer, because here we have got the pneumatic wheels. So the load should not be falling on these pneumatic wheels. Otherwise, that may really simply exceed the rated load capacity of these pneumatic wheels, and it may burst. So in order to protect your wheels from that excessive loads, such backhoe loaders are given with these kind of stabilizers to while working. It has to be engaged. Okay. Let's see some of the components of these machines. Very quickly, we will see that different components. For example, I can zoom in that much. Okay, that is the maximum. Is it visible to you?
Yes, sir.
Yeah, sorry about the
Yes.
font size, but it's convenient. Okay, right? So we have got. Let's start from this bucket. I think now I may not use the pen. So this white cursor is visible.
Yes, sir.
Okay, we have got this bucket, and okay, engine radiator. We know that there should be engine and radiator somewhere. We have got this cylinder, this red one here as the bucket cylinder. Then this is the cab, and what else is important? Okay, we have got this ripper cylinder. So this ripper cylinder, this yellow one, will be pushing this this ripper up or down. So it has got the ripper as well as the dozer in the front. And this one is the final drive. This is the live sprocket. And this gray one, this green one here is the idler. So it is not powered, but it is required uh, in order to do what? In order to share the tension. And we have got these two idlers, so that it is along the length of the chain. It is necessary for structural stability, and in between we have got these rollers. So these pink ones, and these are known as rollers. They are simply rolling. By the way, you may have also noticed, or probably you can imagine, what will happen if I use fewer number of rollers. So instead of 1, 2, 3, 4, 5, 6, 7 at the bottom, what will happen if I use only 3 rollers? What do you think? That's a question. No imagination? Hello?
So sometimes the chain may bend towards the rollers if rollers are less.
Yeah, the chain will bend, but chain is flexible, right? Because we have got these grousers. These parts are known as they are known as the grousers. Okay, let's say here is a better view. So we have got these grouser plates. Okay. Now, what will happen if we reduce the number of rollers? So the chain will this chain will bend. It will follow the curvature of the rollers, right? But what will be the problem of that? You're right, that will be the aftermath. But what will be the final effect on the ground? It will lose its contact with ground at the areas, excuse me, at the areas where there is no roller. That this chain is not being pressed against the soil, right? Because that chain will tend to be lifted in this portion where there is no roller. Am I right?
Yes, sir.
So it will reduce the contact area, and contact area is very important because these chains, they claim their benefit over the pneumatic tires on the issue of the contact area only. And contact area for a given load of the machine will determine and define what is that contact pressure. And contact pressure is something which is a headache, which is a nuisance, typically in the off-road conditions, because we are not having a tar macadam road, it is a soil. So it may create the sinkage for the machinery that you are using if it is having uh, higher ground pressure. We cannot make these machines feather lights. We cannot use aluminum. We cannot use plastic, because the challenge here is that if we have to push or pull something, we also require weight of the machine. So that problem is really complicated, which relates the drawbar ability, that is pushing or pulling, versus the weight of the machine versus the ground pressure. So that is where these chains, they tend to, or tracks, these are the tracks, okay? So these tracks, they tend to offer some advantage, supposedly, over the pneumatic wheels. So we will come back to this point again and again, because that is the heart of the traction mechanics, which is related to the tractor. So once again, let's see the different components of this track. They've got a sprocket. Sprocket is the live component. So it is connected to the engine, whereas the idlers are not. Idlers are simply there to, as I said, to make the longitudinal stability of this entire chain. So it is kept at the extreme end, and in between they are the rollers. So you may expect, or you may actually say that idler is a larger diameter roller. That's it, because it actually creates the shape of the track, and in between we have got these track rollers. More number of rollers, more smooth will be the transition, and more kind of uniform ground pressure will be. So if we will see the ground pressure, the pressure will be high, there will be a peak when it meets the roller. Okay, just below the roller, the pressure will be high, because between the two rollers, the chain will be slacked. It will not be tightened enough to transmit the pressure to the ground. And here we have got the recoil spring. It is not bare open like this, but it is a cut out, so that we can see underneath in this part, not here, not in this one, but behind this there is this component which is known as the tensioner zone. This zone is having this kind of recoil spring, which is playing an important role in order to uh, to create a tension, so that this chain remains straight underneath. Okay, I think that's it. Yeah, one more thing. This is known as the track shoe assembly. These are the shoes, and we have got one more term to be noticed here. That is the pitch of this chain. So pitch of the chain is you can see maybe here. No, maybe here you can find out. This is the pitch of the chain. All right. Now let us see different components of an excavator. See if that can be zoomed. Yes, it can be zoomed in. We have got from where I should start. Okay, let's start from the main component, the bucket. This is bucket, and this one is known as the bucket teeth. This is H link. There are different designs available for these linkages. Sometimes these are H links design, sometimes they are Z link design. So it depends on what kind of uh, manufacturer has set the design for you. These are known as the dog bones or side links. These are the kind of the technicians' slangs. They call them as dog bones, but because they look like that. But these are basically the side links. And I will come back to this cylinder later on. First, let's look at this main component. This part is known as a stick. Stick is not an integral part of the bucket. That should be swivel. So at this point, we have got a swivel. We have got the rivets, of course, larger ones. So bucket, stick, and this portion is known as the boom. So we have got the one cylinder or one muscle which is connecting the boom to the stick is known as the boom cylinder, or some also call it as a dipper, arm, or stick cylinder, or crowd cylinder. So it has got different names, but you can also remember it as a boom cylinder. Then we have got this cylinder which actually activates which controls the fingers. This muscle is known as the bucket cylinder. So it is fairly inspired by the human anatomy, where we have got the tibia or femur. So from the shoulder there is one bone, and then we have got another bone from elbow to the wrist, and there is different muscles which operate the shoulder, and we have got different muscles which operate the fingers. So the similar concept is here. We have got the gap, and essentially it is fitted with the roll over protective structure, ROPS. We also have a FOPS, falling object protection structure, FOPS. So we'll see that in their different tractors. And at the back side of it, there is an engine which has got almost everything what it requires. And now the crawler part of it, this is a steel track. Yeah, looks like steel track. Yeah, that's a steel track. And these shoes are also known as the grouser pads or track pads. And by the way, you may have noticed that this top portion is mounted on a turntable. And since it is mounted on this turntable, you can swing it. In many cases, you can actually swing 360-degree, and you can actually come back to the same place and you can continue to rotate, because it is it is important feature in order to move the material radially outward. So here we have got this swing, we have got the track adjuster, tensioner, we've got these bottom rollers, which are known as the track chain or rails. This is the sprocket. Like that, we have the different components of an excavator. So next time, whenever you see a JCB like that, or an excavator, aka, you can try to identify its components. And yeah, that's another view of it. We have got this boom cylinder, we have got this arm cylinder, and it is also known as the bucket cylinder. So that was not visible in that previous view, I guess. We have got this cylinder which actuates or activates this arm, this boom, and then we have got this arm, and this is the stick, and this cylinder is for the bucket cylinder, and that is the turntable on which the entire assembly can move. And I think that's quite a nice image I found on internet. I didn't make it, obviously. And here is a swing motor. So this motor helps in rotating this cab along with this boom and the arm and the bucket all over this stationary crawler platform. Okay, and the next thing is the backhoe. So let's see what we have special in this. These backhoes are, this backhoe is actually having the pneumatic tires, pneumatic wheels. We have got this cylinder, which is known as the loader lift cylinder. So it will lift the loader. And this cylinder is the loader bucket cylinder, because it is actuating the bucket. It can tilt the bucket, but in order to lift the entire assembly, you have to make use of this loader lift cylinder. Here we have got the loading bucket, and this is the loader lift arm. Obviously this one is a cap. We have got this backhoe. In the back side of it, we call it as a backhoe. So it is the backhoe's boom. This is the backhoe's arm, and we have got this rock bucket or the backhoe bucket. It's a rock bucket because it has got teeth which are strong enough so it can actually scratch onto the rocks in order to break them and load it into it finally. This arm is interesting one. It is a swivel arm. So the entire tractor need not to be reoriented, but only this backhoe arm can be rotated on this swivel frame. And then we have got this swing cylinder, because in order to rotate it, it needs to be powered, and obviously it is not being powered by the PTO. It is entirely powered by the hydraulic system or hydraulic circuit of the power of the engine. So the engine's main role is number one, to generate the hydraulic pressure, and number two is to carry the load onto their pneumatic wheels. That's it. And if needed, it can also run an air conditioner in the inside this cab if the driver is a lucky one. And we have got this stabilizer arm with the cylinder, because that also needs to be powered by the cylinder. So you retract it and then push it towards the ground so that it can make a firm contact. You can also see that there are the rubber shoes, so it does not damage the ground, obviously to increase the pressure, distribute the pressure while you are carrying the load up or down. So that's well, we have talked about the H linkages, and this is the geometry for the front end loader. It's a front end loader, so as you can see here, the direction of swinging is upward. So it is actually, here we have got the tractor, so it is pushing uh, in front of the tractor. So that's why it is known as the front end loader. So this cylinder is the lift cylinder because it is responsible to lift it, and this cylinder is the tilt cylinder because this cylinder, once it will move outside, this will be pushed backward, and this loader will, this bucket will be moved upward. So they have got, as I said, different geometry, and probably this is enough for the time being to understand these different components, at least to make ourselves familiarized with these different off-road vehicles and machines. Shall we take a short break? Maybe 2 minutes, please.
Yes, sir.
Okay. In the meantime, if you have any query, we can discuss. Do you have any query? All right. So, am I audible again?
Yes, sir.
Okay. So let's see the functions of off-road vehicles in a more technical term. These are the complex machines. Off-roads are the complex machines. We know that complexity is mainly coming from their interaction with soil or the terrain, and their main function is to propel and power a large variety of implements for agriculture or construction or forestry production or sites. These implement applications have considerable effect on the vehicle design. So the design of a vehicle is not for the comfort mainly, and it is not also for the speed. So the vehicle design is governed by the factors for which this off-road vehicle has to be designed, obviously. We have already talked in the previous subject last semester that there are a number of ways how you can attach an implement or a working device or a working tool onto a tractor. It could be towed, it could be mounted 3-point hitch, it could be frame mounted, and in between there exists a semi-mounted also on a 3-point hitch. We'll not talk in detail about it. So once we have identified for what purpose this off-road machine or off-road vehicle has been designed for, then we can talk about its performance and its evaluation. As we have talked earlier in the in different uh, meetings, that when we have to evaluate something, we first need to ask ourselves for what purpose that object or that prototype is designed for. So accordingly, the metrics for the performance evaluation has to be created. So metric is important. You cannot really uh, evaluate the performance for something for which you are not supposed to be designed to. So that's why it's very important to select an appropriate metering to evaluate the performance. So when it comes to the off-road vehicles, all right, let's start with the on-road vehicles. We have different metric which are associated to the on-road vehicles. What they could be for Indians, and why only Indians, but to the entire subcontinent people. This kilometer per liter is probably the first and the foremost metric to that to be tagged with your passenger vehicle or on-road vehicle. That is the mileage. That is the fuel economy in terms of mileage. But when it comes to the performance evaluation of an off-road vehicle, we simply cannot compare. Look, my tractor gives 5 kilometers per liter, but your car gives 25 kilometers per liter. No, this way we can't really compare because the two things are just too different. So, hope you understand that. So, we have to now define a different set of metric which are associated to the evaluation of a off-road vehicle, because their ability or their performance refer to the ability to overcome the motion resistance. So for example, for an off-road vehicle, its ability, yes, proudly some can say my off-road vehicle can overcome cuts run. There is a uh, kind of run, right? Kutch run in Gujarat, which is quite a meadow. So if your vehicle, if your off-road vehicle can drive on that track, it is a matter of pride. So it is a vehicle's ability to overcome the motion resistance, or it can be also seen in terms of how much the off-road vehicle develops the drawbar pull, or how much it can negotiate the grades. So sometimes there are 4x4 rallies where they tend to show that, yeah, my car or my off-road vehicle can climb 30-degree grade. Somebody would say, okay, my vehicle can climb 40-degree grade. So that's the metric which are associated with the performance evaluation of off-road vehicles, or it is also related to accelerate in a straight line motion. So depending on their intended use, that is the key, we have different set of criteria to check the performance of different types of off-road vehicles. For instance, a JCB or an excavator in other words cannot be compared on the same metrics on which you are evaluating the performance of your tractor, of your farm tractor, because the intended use is different. We have got Arjun tank. The performance of an Arjun tank, which is a battle tank, cannot be just compared with that of a JCB or with that of a tractor, because there altogether the expectations are different. So that's why in order to evaluate the performance, we first need to check what type of vehicle, off-road vehicle it is. Is it for agricultural use? Is it for transportation use? Or is it for the military purpose or military use? Let's begin with agricultural use. And when it comes to the agriculture, we have our own tractor, and for that we check that its prime function is to provide adequate draft to pull or to push. So we are more interested in the amount of pull it makes or amount of push it makes, maybe in terms of plows, maybe in terms of the dozer blades. So the prime function of the tractor is to pull or to push to generate the traction. So here the drawbar performance is of extreme importance. So we check the performance of our agricultural tractor or whatever machine that we use for the as a prime mover for agricultural use. We are interested on its drawbar performance. How much drawbar it can generate, how much power it can transform from axle to the drawbar, because it is very important from the agricultural viewpoint. Then it can be expressed in terms of a ratio called the drawbar pull coefficient. So the pull coefficient is the ratio of how much pull this tractor is able to generate to that of its weight. So it's P by W. So this is also known as the drawbar pull coefficient. So it is important. This P by W ratio is extremely important, because as I said at the beginning of today's discussion is that W is important from the viewpoint of ground pressure. So we want it to be lighter, but at the same time we can't make it too light that the P, which is expressed as a fraction of the W, is also lost. So a lighter tractor or a tractor, let's say 1,000 kilogram tractor, can never generate a pull which is more than its own weight. And we know that because of lot of inefficiencies, getting 100% pull coefficient or coefficient of traction is never possible. So if we are intended to make 1,200 kilogram pull, obviously we have to create weight on our tractor. So that influences the design. Now, that means heavier the tractor, will it be better? That is also not true, because heavier the tractor, more will be the ground pressure, and then there will be more problems. So that's why then people talk about the tires. People talk about tires dimensions versus the track's dimensions. Then people also talk about ballasting, that not every time you are to generate 12 kilonewton pull, 1200 kilogram is roughly equal to 12 kilonewton, isn't it? So not every time you are required to generate that 12 kilonewton pull. So what we do is we keep our tractor 800 kilogram, but whenever you require this 12 kilonewton pull, you can add ballast to the drive wheels or to the traction wheels. You can add weight, ballast. That's a technical term, and it will definitely eat up your brain for at least half an hour sometime soon. So this ballasting is an additional or aftermarket addition of the weights to the drive wheels, so that you can achieve that necessary tractive coefficients. Then the next metric we have already seen is a drawbar power, which is pull times the forward speed. Drawbar pull times the forward speed. So that is the drawbar power. And then we have the tractive efficiency. So it's the ratio of the drawbar power. So it's pull times velocity. It's a ratio of power to power, right? So if the output power is a drawbar pull times actual velocity, then we have input as the input power, input XL power. We cannot say here the total tractor power because we are not using that entire power to get it converted into the drawbar power, right? So we have got a series of inefficiencies. We have got an engine. Engine gives us brake power. That is something which you expect as an output from an engine at the flywheel. From that engine, it has to pass through. By the way, even within the engine, some power is gone to the cooling. Some power is gone to overcome lot of frictional resistance, etc. Then whatever power net you get as the output from the engine, you have got the transmission. So from the transmission here we have got the gear selector lever. So we are making different sizes of gears. There are shafts, counter shafts, and main shafts. And then one shaft goes to PTO, and this shaft is an output shaft. From this output shaft, we have a differential. This is a differential, and from the differential it goes to left side wheel, right side wheel, and then for each wheel we have got the not that big. It should be small, and then we have got a kind of larger gear. This is known as the final drive, and from final drive, then finally we get our tractor. Okay, this is our tractor wheel. So I'm just showing only one side of the wheel. That's a lot of things which are built into it. From engine to the transmission, one efficiency. From transmission to the differential, another efficiency. From the differential to the final drive, this is known as the final drive. There's another efficiency. Now, whatever XL torque we get here, let's say this is the torque, XL torque, which is rotating it at omega. So drawbar pull times forward speed, forward linear speed divided by tau omega, right? Because that tau omega is what we provide this wheel to generate or to transform it into the necessary pull times velocity. Hope this sketch or this schematic is clear, because that is the basis of traction theory. And as an agriculture engineer, and especially if you are taking this subject, it is very essential that you understand this this big picture of a tractor along with its traction device. Hope it is clear. I just want to listen. Yes.
Yes, sir, it's clear.
Sir, I have a doubt, sir, actually.
Yes,
So
please go
this
ahead.
tractive efficiency, drawbar per, are these not instantaneous values, sir? Because they will have different forward speed at different points of time, right?
Obviously.
So then how
Obviously,
can we
tractive
compare?
efficiency is not depending on the gear selection. Gear is doing what? This gear is changing
Just
which parameter?
changing the ratio between the torque and the pull.
No. Yeah, that's okay. Yeah, please go on. Torque and
Torque and the force.
speed, right?
Yeah, speed.
Okay. So higher the gear means lesser torque and higher speed.
Yes, sir.
And lower the gear means?
High torque and less speed.
Okay. That means the product of the two remains constant?
Oh, yeah. Yes,
Because
sir.
power is constant.
Yeah.
So it is a trade-off between pull or, okay, let's not talk about the pull, because pull is coming at a different outlet. Let us first talk about the transmission or the engine. So gear, that actually has a trade-off between torque and omega, right? Omega, that is the rotational, that is the rotational speed. So higher the gear, omega will be more, but at the cost of the torque. But the product of the two, tau omega, remain constant. So that is why we have a single value, supposedly, of the tractive efficiency from a tractor. So it will not depend on the gears. Did I answer your question?
Yes, sir. But then this forward speed will change at different point, right?
Yeah. Let me explain. That forward speed will change not as a function of the gear selected anymore. Once you have selected the gear, your control on the tractor is now done. You cannot change the other parameters. You agree with me?
Yes, sir.
Okay. Now, what are the uncertainties because of which the tractive efficiency will be different? That let me explain now onwards. Now, what happens? First, let us understand what is the input power. Let me zoom in. What is the input power to this tractive device? Now, the tractive device, mind that word, not the tractor. Here, this is the tractive device, right? The wheel. What is the input power? T omega, right?
Yes, sir.
That is the axle power. It's power, right? Axle power. The power which you are providing this wheel to generate the output. Now, what will be the output from this tractive device? That is the pull, because this pull, well, I am showing it on this wheel, but actually it is at the it is at the tractor itself. It is the entire frame itself. So, but that is generated by this tractive device. So this tractive device is generating the pull, and it is pulling the load at certain speed, right? That's why we get the output from this traction device as pull times velocity. Is that okay up to here?
Yes, sir. Yes, sir.
Yeah. Now, the magic which is happening here is in terms of speed. Which speed you are taking into consideration? Of course, the linear speed, the linear forward speed, but is the r omega, we have got the wheel here and its radius here and omega. So what will be the forward speed that you are considering? Are you considering the r omega or are you considering v? Now you will be asking that both are the same. No,
So we are considering V, right?
both are not the same,
Yes, sir. Both
because
are.
in practical situations, and what is that practical situation, by the way?
Slippage.
That is the ground, on which the terrain on which your tractor tire is moving. So that is creating this entire magical phenomena of slip. Now, because of that slip, this forward speed is actually the actual forward speed, actual V or VA, not the theoretical V. This is theoretical V R omega. There's one more thing which is happening, another magical phenomena, the weight transfer. The radius that you are assuming R is not going to remain same throughout the operation. Now you may be wondering what I'm talking about. Let me explain. You have the constant pressure. Obviously, there is no puncture in the tire, so whatever air you have filled in, that will remain in the entire volume. And we assume that this pressure reading is not going to change much. But what is happening? Since it is a low pressure tire, it's a low pressure tire, right? So what happens at the interaction area, at that patch area, this tire tends to flatten, and that is known as the deflection. Because of that deflection, the radius here is shorter than that of R. So this radius is known as the rolling radius. And why this rolling radius cannot be determined so easily? We can mark it with a chalk and then let it dry for a number of revolutions, and we can measure the distance. And we know that this is 2 pi r. You know, it's all 2 pi r thing. We can find out the rolling radius, no problem. But that still remains as unloaded rolling radius. What happens when there is a load onto it? Load on the tractor device, that is actually coming from the load of the tractor, right? Load of the tractor will be shared by the four wheels, and you know, so like this. So that load is known to us, and even in today's lab we are going to find out the reaction. Reaction means what is the load shared by this tire. So what is so big deal about it? Now big deal is because of the phenomena called weight transfer. The weight is being transferred, once again linking it to the previous subject, previous semester subject. Weight transfer is occurring from the implement onto the tractive elements or to the tractive devices. Weight transfer is happening from the front wheel to the rear wheel. That is also weight transfer phenomena, and that weight transfer is depending on the pull. So since the pull is not constant, slip is not constant, that is why it is not possible to have a unique and constant value of the tractive efficiency, or whatever this drawbar pull coefficient or whatsoever for a given tractor. Now hope you got the bearings.
Yes, sir.
Okay. But I really request all of you that this is a conceptual discussion, and please try to save it, or please try to kind of remember it, because it is really going to be helpful to you to understand most of the concepts related to the traction and that of the tractor. Okay, I hope that this is being recorded with all the blah blahs, but in between there are some useful things. You may either take screenshots or you can follow the recording later on. Shall I move on?
Sir, I have one more doubt also.
Yes,
So
go ahead.
basically here, how do we measure the torque, sir?
Which torque? Wheel torque?
Wheel
Yeah.
torque.
Yeah. Strain gauges. Strain gauges. These are these are basically the conductor wires. They are although formed like a coil, but actually these are not the coil. These are not inductor. These are conductors. And what happens that when you pull a conductor, its resistivity remains the same, right? But resistance change. Agree?
Yes, sir.
And somehow if you paste means really glue it onto the shaft of the tractor or any shaft. So if the shaft is twisted, then the micro length of this conductor will also change, right? Now, since these are the foil type strain gauges, so these are having a bit of a flattened surface, not just like this cable, but these are very thin and very sensitive material. So they are more sensitive to the change in the and maybe smaller change in the dimensions. So what we measure is actually the drop in voltage or the change in voltage, which is corresponding to the change in the resistance. Now, change in resistance, let me write it down. Change in voltage, which is being measured, is corresponding to the change in resistance. Now the change in resistance is corresponding to the change in strains. This is a strain. Okay, and the change in strain is corresponding to the applied load. So by measuring this, we are getting some clue about the applied load, and that we have to calibrate because it actually does not measure the torque, it actually measures the force, because it actually measures the strain, and strain is in accordance to the applied load generated by the torque at the known reference plane. So that calibration curve is there, and then you can simply measure the no, delta V will be on now what is unknown going to be? Unknown is going to be the applied torque. So Y is equal to mx plus c. Unknown is T, is expressed as a function of change in voltage. We can get the torque. Is that okay?
Oh, okay. So this y is equal to mx plus it's not fixed, right? Because it depends on the material of this strain.
Yeah. That's why there is a calibration which is needed for every strain gauge or every instrumentation that you put. So actually, it is a part of the instrumentation course. Unfortunately, I'm not offering it now anymore, but yeah, it is explained there.
Okay.
That calibration is must for each instrumentation that you put. But normally, the tractors are not come fitted with these kind of torque sensors. You have to either buy it or you create by your own. But there is a method that by which you can measure the torque. Omega, of course, you can measure. There are radar sensors available. There are proximity, this magnetic Hall-based proximity sensors are available. So by using different sensing techniques, you can measure the omega, you can measure the torque. A drawbar pull, you can of course measure. How do you measure a drawbar pull? It's like the that kabaddi wala's spring balance. There's a hook and then there's a dial here, and it has got the spring, and here you apply the load, right? So you can check the load. Same way you can, if it is a hitch implement, right? If it is a trail type implement, not the mounted type. If it is a trail type, you simply put that spring balance in between the trolley and your tractor's drawbar hitch point, and then you just pull it. So you can measure the pull load. Pull is a force, right? Its unit is Newton. It's a force. Drawbar pull is a force. Here P is a force here, not the power. Here P is not power. It is sorry, I should write it in Newton, and Newton by Newton. That's why it's a ratio. All right. So this way you can measure the drawbar pull, and slip you have to measure. For slip measurement, I think there will be one of the labs to measure the slip later on. Is that okay for the time being?
Yes, sir.
Okay. So that was all about the agriculture. Since our main task of this subject is to talk more about the agricultural uses, that's why we spend more time on it. But for transportation activities such as trucks, or which are used in mining or in logging industry, the time rate of transporting payload. So from point A to point B, the time rate. So that is the product of payload, that is in terms of kilogram. Well, it's truck, so we are actually talking about the tons or tonnage. So the payload and the average vehicle operating speed. So we accelerated from A, and then we reached to the max speed, and then we maintained sometime maybe around here, and then we reached to the point B. So we had to find out the average speed, and which is kilometer per hour. That will be multiplied by, let's say, the ton. So it is kilometer ton per hour. So that is the transported productivity. So kilometer ton per hour is the transport productivity from origin to the destination. Now, what is the transport efficiency? That is the ratio of transport productivity, which is kilometer ton per hour, to the corresponding power input. How much kilowatt you have, that's how much kilowatt or watt you have supplied into in order to get that work done is known as the transport efficiency. That's straightforward for transportation. Now, although it is not really our main interest, but it is important to understand that how the intended task change the metric. For military vehicles, have you ever heard of how much fuel consumption value is for F-16? Or what is the fuel consumption of Chinook? Have you ever talked about it? Have you ever uh, even cared to know the fuel consumption of that or mileage of a Arjun tank? No. Because the fuel consumption simply does not fall into the priority of the intended use. That is a military vehicle, that is a battle vehicle. So there, spontaneous reaction is more important. The speed is more important than how much you spend to get that speed. We never say that. We never compare Sukhoi versus MiG-16 in terms of the fuel consumption. Okay, well, we request the defense minister that no, please next time whenever you go for shopping, please find out the fighter jet which has better fuel efficiency, better mileage. No, their mileage is no longer an issue. The issue is the precision. The issue is how quickly you can take off, what is the payload, how long you can survive airborne without refueling, and what is the operating circumstances you can maneuver at. Can you fly very close to the ground? Can you do aerobatics very lower altitudes? So those metric become the metric for evaluating the performance of the military vehicles. So there, the important thing here is the military related issues. So the function of mobility with speed. So those are the important things related to the military vehicles. Okay, so if I were to evaluate the performance, the fuel consumption overall, that has been a common expression for mainly for the on-road vehicles. However, for the off-road vehicles, we are more interested in terms of these SFCs, specific fuel consumption. That is the liter per kilowatt hour. So liter per power, that fuel consumption rate per power output. So fuel consumption rate, the rate is liter per hour per BHP or per HP or per kilowatt. So that becomes the specific fuel consumption. Okay. Now it is about a little bit of the history of a tractor. So far we have talked a little bit of the technicalities. Now let us dive into part of the history of the tractor's evolution, how the tractor has evolved over the time, over the period in terms of its capabilities. It has all started with very basic tractors like like the one which is kept on your left hand side. Let me zoom in. It's good to see these historic pictures once in a while to remind ourselves that where we have come, so like how far we have come in terms of the development. These are the early models of the tractors. Really the tractors, in this tractor there is I think coating of rubber, and this is steam powered, so this is an external engine, right? External combustion engine. Here this is all iron wheel. So difficult it was to, and you can see this crank that used to be available in 1960s movies, where there used to be lorry, not the truck. Those lorries, they use, somebody will come out and will rotate it, crank it in order to start the engine. Then these are the rubber kind of coated or rubbered iron wheels. Look at the size of this exhaust, and I think this is used for brake and very long steering. And forget about that power steering. If this wheel gets turned because of a big stone in front of it, the wrist of this operator will sure be broken. So then these small wheels. Here it is three wheels, right? Only one wheel is there. So I think this is steered by the rear wheel. Although differential is there, and what you can see here is a large pulley, right? This is a large pulley. Now in earlier days, that used to be in a very important power outlet where somebody will mount a belt on it like that atta chakki. You remember that? That traditional atta chakkis where large belt is there, canvas belt is there. This canvas belt will run a thresher or maybe a water pump for irrigation. So that used to be the power outlet, important power outlet. Now here we get the all pneumatic wheels with 3-point hitch is also there. It's quite a traditional tractor, quite a standardized tractor, and you can see this articulation, right? You know this inclination, sorry, not articulation, but this inclination, because this is the towed wheel, this is the steered wheel. So, smaller front wheels. It has been traditionally known that smaller front wheels reduces the steering effort. So that's why the front wheels are kept smaller. Now we have got this looks like equal size wheels to me. I'm not sure if it is because of the angle or what. Then we get these this tractor. By the way, can you tell me which of the two which are in front of you is two-wheel drive? The green or the red? Which tractor is two-wheel drive?
So the green one.
Okay. And how did you know that?
With the wheels.
Okay. What did you see in the wheel?
In the red color tractor, there is more, what to say, the with
Lugs.
that kind of shape, the traction will be more. So when you
Right.
kind of steer the wheel, we get uh, more grip with the soil.
So these are known as the treads. So you can check whether this tractor is two-wheel drive or four-wheel drive. One symptom is by looking at the tread patterns. These are known as the tires tread. So here this is a ribbed pattern and this is a chevron pattern, chevron or lugged pattern. So this way we can talk about whether this tractor is going to be two-wheel drive or four-wheel drive, because this wheel is not a traction wheel. This is just a steered wheel or implement wheel. You can also see here this implement wheel is not a traction wheel because it it cannot slip. In order to slip, you need to have more R omega, right, than the actual velocity. So if there is no omega supplied, and omega is supplied by the torque, right? If there is no torque, there will be no omega, no induced omega. So no induced omega means the wheel can only serve the actual velocity. So it can serve only the actual velocity, then there is no point of slip anymore. You're getting the point? So the unpowered wheels do not slip. At the most, they can skid. Okay, that's enough for now. I will explain later on what is the difference between slip and skid. We have got these steel cage rear wheels, which are quite popular in India. You see, these are a double steel cage wheels. There's no rubber wheel at all. That's, by the way, Mahindra tractor, and I think that's Tamil Nadu number plate. So this gentleman is doing rice farming in muddy field which is unfortunately not puddled properly. Why I am tending to say so? I can look at this grass. Had this field been rotavated using a rotavator or rotary tiller, you would not see this kind of standing grass in the field. So which means this may be a poor fellow who has no rotavator. So he did not use a rotavator. He simply flooded the field, let it settle for maybe 4 or 5 days or maybe up to a week or so after the harvesting of the previous rice crop. And now he is bringing his tractor, which is with removed pneumatic wheels and fitted with the double cage wheel. So this is a cage wheel, and by the way, this cage wheel uh, is made very much locally because it has got not the chevron lugs that might helped him in traction, but these simple wheels are just churning this this mud. It's a mud because it is soil plus water, and as you can also observe from the front wheel, it is ribbed, not the uh, not the lugged. So it is a two-wheel drive tractor. Okay, that is it. And this has got no ROPS, roll over protection system. Do you think that it has got the ROPS? No, don't get confused with this canopy. Okay, it's a canvas canopy. It cannot be used to safeguard the head of this our friend here. If this, unfortunately, in some situations, if that tractor back flips, or if this tractor makes a side turn, then the head of the gentleman will be crushed. This structure is not strong enough or not scientifically designed enough to protect this person or the operator. So it is not an ROPS. It is simply a canopy to save it from sunshine probably. Okay, although I'm the one who do not like history, but uh, I tended to summarize some important historical milestones which are related to the development of a tractor. Don't worry, these details are available in a chapter which I will be also sharing with you probably today as a reading material, so you can read it through. But let me summarize. 1858, steam plowing engine by Fox. 76, Otto patented his internal combustion engine. So before that, it was no concept of the petrol engine, no concept of diesel engine. That was only the external combustion engine. That is a steam engine. In 1908, the first Winnipeg tractor trials were held. These are historical dates. And just before the World War took place sometime during 1914, right? So 1910 to 1914 or so, first tractor demonstration held at Nebraska. Nebraska has been a vibrant place. So that's why, Nebraska test codes, they are very famous. Nebraska test codes. And we are still using these test codes in OECD, and we are also using the Nebraska test codes for our Indian standards. Earlier it used to be as BIS, but now it is renamed as IS, Indian Standards. We are also following most of their test protocols, testing a tractor. And during this era, the smaller and lightweight tractors got introduced. The frameless type tractors also got introduced during this era. Then, in 1920s, uh, they developed the all-purpose tractor, and first PTO was developed during this era. Before that, there was no PTO. So the PTO was in 1920s. Then let's see what happened in 1925. The PTO was adopted, and the ASA published its first PTO standard. So that's ASA is now ASABE. So they created their first PTO standard. So now that PTO was standardized. In 30s to 37, the diesel engine was applied to larger tractors. Before that, there used to be the petrol engines, but petrol engines are now the gone case, and people have switched to the diesel engines, and pneumatic tires and high speed tractors were introduced, and there were more modifications in terms of the engine development. So the engines were now designed with higher compression ratio. Later on, we will see that how compression ratio improves the thermal efficiency. And the first wheeled diesel tractor got tested at the Nebraska. It is exactly the Nebraska Lincoln, where the University of Nebraska Lincoln is there. Then we got standardized ASAE and SAE. SAE is another important body, Society of Automotive Engineers. They also, along with John Deere, they have this TFAN. I think this year you have missed that opportunity, but if you are ready, please prepare with your team to participate in this TFAN SAE John Deere challenge competition for the tractors and agriculture machinery. And the pressurized cooling system was introduced. Before that, that cooling system was mostly either air cooled or just a simple water jacket cooled, not pressurized system. But in today's tractor, we have the pressurized cooling system. That's why they say don't open the cap of the radiator when your engine is on, whatever engine it is. Not your scooter engine. Scooter engines are mostly air cooled, but your car engine or your tractor engine, don't dare to open when the engine is on. Liquid ballasting to add traction, as I was describing that for a wheel, how much pull it can generate is a function of W, right? So if we require more pull, we simply need to add weight to it. It is as simple as that. So how we can add weight? We can attach some, dead iron pieces onto it. We can even add rocks and bricks and all. That's a crude method. There's one more method, is liquid ballasting. There is a nozzle. So you simply use this maybe a special pump, connect it with the water hose, and then push the water inside. At the same time, you need to remove the air out. Okay, so that's why this is a specialized pump. It has got two hoses, so it sucks the air and fills it with water. And if you are using that water in cold areas, don't forget to add antifreeze, otherwise your tires will be gone. So we have to fill this uh, this tire fully. No, we can't fill it fully, because we have to give allowance for deflection, and we know very well that water is still considered to be non-compressible fluid, right? So we can't fill it fully. We have to fill it up to maximum up to 75% of the volume, that to be filled with liquid, that is water. That is known as the liquid ballasting. Before that, that concept was not there. Then we started having the 3-point implement hitch, and then linkages got introduced. It is as late in 1940. Before that, so PTO is an older technology. And then came the Ferguson. So Ferguson designed this 3-point linkage, which is still popular today. And what next? Then came the concept of the live PTO, and even people started using using LPGs for their tractors. I know I have got 2 more minutes, so let me just flip it through. And the power of tractors during 50s and 60s, it keep on rising rapidly. Now the tractors started getting more and more powerful. Power steering got in picture. Before that, it was just a manual steering. Remember that lorry truck driver? So hard it was to operate. Transmission with more number of gears. Even today, we get up to maybe 24 forward and maybe 12 reverse gears. So many gears are there. And last LPG tractor got tested at Nebraska. After that, LPG, bye bye. Then we had this anything special here? Yeah, full power shift transmission, radial ply tires, and planetary final drives. So final drives were instead of this simple bull gear type, we have now got the planetary final drives. Epicyclic gear drives were also introduced as a final drive. Power tillers started getting popularity in Japan, and okay, that is it for today, and tomorrow we will continue with our pictorial tour. More and more pictures, only pictures, no words, not at all. And then we will conclude this session. So that's it from my side today. If you have still any question, you can check with me now, but I guess that you have another class.